morning, y'all. Welcome to another fabulous episode of How Many Tabs Are Open on Mr. Johnson's Computer? Two, four, six. Six, and I even opened up the stuff for today already, so I'm doing good today. So this is your activity for today, math, April 8th, week 25, activity 2. It's a Google assignment, so if you go ahead and click on it, you're going to get a scatter plot. I almost called it a stem and leaf. This is not a stem and leaf. A scatter plot, all right? So things to remember from yesterday about scatter plots. Scatter plots still use your x-axis for running, your y-axis for jumping. All right. So it is kind of like a coordinate grid. Some people were making that connection yesterday that it kind of reminded them of the coordinate grid that we were graphing on before. And it's the same idea, except before we had an input output table that followed rules. So the input and the output would have a rule. Like we would add to that x or our input and we would get our y, or we would multiply our x and that would give us our y. But scatter plots are exactly that, scattered data. All right, so the data is scattered everywhere. It does not follow a pattern. So when I can't get things organized in my head, I call it being scatterbrained. All right, and that's when I feel like all the data in my head is swimming around and does not follow a pattern. All right, so a scatter plot is just that. This will not follow a pattern that applies to every single piece of data. However, we can find a pattern like they talked about yesterday in your play posit. For instance, if you have a graph and it starts at the bottom and starts to go up and to the right. Um, if you have that going on your graph, that's a positive correlation, right? As the x gets bigger, the y gets bigger. Now, if you have a graph and it starts on the like higher on the y-axis and starts to go down on as it goes further on the x-axis, that's your negative correlation. All right, so basically, then if you just have dots everywhere and you can't find a pattern, then there's really no correlation. All right, so we're going to try and find a correlation on this graph if there is one. But first, what we have to do is plot all the points. All right, so these are all your coordinates. Even though these are listed HW, this is X and Y. So they called this H because it does represent your height, and they called this W because it does represent your weight on the y-axis. So your height is your x-axis, your weight or the weight is the y. All right. So what we're going to do is we're going to run the h number and we're going to jump the w number. As you can see, the origin on this is not 0, 0. Scatter plots can start like in random places. As you can see, this one starts at 62. This one starts at 125. It's because if you look at the data, um, our smallest number is 61, so it's probably going to go somewhere between right here and right here. And then our largest number in our input side was 67, so that's why 67 is up here. Our smallest number on our output side looks to be 127, so I think that's why they started around 125. All right, so the scale on a scatter plot can be a little bit more complex because they are not starting with 0, okay? So a lot of the times on these scatter plots, like they will create the scale for you, okay? So let's go ahead and look. So our first plot point is 63, 145. So we need to take a point and we need to run 63 and we need to jump 145 and put a point right there. Boom. Our first point is labeled. If you want to make things even easier for you to know what you did already, you can just cross that out. Thank you to people that were crossing out things on their last Google assignment after they used it. It's a really, that's what you would do if you're writing on paper. So it's a smart idea. Remember, don't like black it out to where you can't see the numbers, but just crossing it out shows you. I used it. I can still read that that's 63 and 145. All right. All right, so next point, I'm gonna do 65 on my input, 148 on my output. So I'm going to run 65, and I'm gonna jump past 145, but not quite to 150 because it's 148. So somewhere between 145 and 150, 148 is right about, actually, if you think about it, 45, 46, 47, 48, 49. Yeah, so right about there. 148 is halfway between 145 and 150. So the next plot, oh, let me just stay consistent. We got that one. 65, 148 is taken care of. All right. Next one, we have 61 as our input, 127 as our output. So we're going to run 61, and then we are going to jump to about 127. So about 127 is going to be between 125 and 130. All right. So we have our plot point where we ran 61. Even though it wasn't labeled, we know that that's 61 because here's 62. And each one of these skip counts by 1. So that would suggest that we're starting over here at 61. All right. So let's go ahead and take our line, cross that one out. And let's go ahead and get the next point. 67 is our input, 150 is our output. So let's run to 67, and then let's jump to 150. Boom. That is by far probably going to be the largest piece of data on our graph. You got it though. All right, next one that we're going to look at is 65 and 142. So if you are 65 inches tall, you might be 142 pounds. And that's kind of what they're saying, is like they are trying to compare height and weight. So they're trying to say, if you're taller, do you weigh more? If you're shorter, do you weigh less? Next point is 66 is our input, 147 is our output. So we're going to go onto our x-axis, our input, and we're going to run 66. Then we're going to jump 147 on our y-axis. There we go, 66 and 147. I put the 147 like slightly below the 148. If we want to move that up just a little bit to show the difference too, we can do that. So there's 147, there's 148 from earlier. So they should be pretty close together, but not in the same place. All right, the next one, 63 and 137. I'm going to take this point and I'm going to run 63 on my x-axis because that's the height, 63 inches. And then I'm going to jump 137, which is the weight. So someone that weighed 63 inches weighed 140 or 137 pounds. So we're going to put our dot right there on the y-axis at about 137. Means we have 2 plot points left. We have 62 and 130. So this person, they weighed 62, or they were 62 inches tall, and then they weighed 130 pounds. So we'll put a plot point right there at 62 and 130. That leaves us with one last piece of data. All right, and so let's take our last piece of data, 64 inches and then 136 pounds. All right, so the last person that they collected data for was 64 inches tall and they weighed 136 pounds. All right, so now here's the cool part. We can apply some of that data or like information that you learned yesterday about positive correlations, negative correlations, and no correlation. So let's take a look at this. And actually, let me use an arrow. Okay, so let's take a look. If I draw a line like this, does it seem like a lot of the information follows this line? Let's see. It kind of does, right? So there's a couple pieces of data that don't really follow the pattern as closely. These two up here, they're kind of a little bit off of our pattern here, but if you can see, most of our dots are really close to this line. So what that does is that suggests that there is a, sorry, I gotta do this backwards. There we go. That suggests when the line is going up that there is a positive correlation. All right, there is a positive correlation. What that means is the taller people are, the more they should weigh. All right, typically. Obviously, this does not count for everybody. We have people of all shapes and sizes, right? So, but it looks like, according to this graph, the people that were measured and weighed, the taller they were, the more they weighed. And we can see that because the arrow goes up. All right, so here's the thing. Let's say that the arrow went down, and that would be ridiculous probably because of the fact that because that would suggest that as you get taller, you weigh less, which doesn't really make sense, right? But we would see dots headed downward, all right? And we don't see many dots following this line, do we? And since there's not many dots around this line, that means that it's not a negative correlation because most of the dots are going the opposite direction. So what we have is we have a positive correlation because if I draw a line going from the bottom of the left to the top of the right, most of the dots are right around that line. They don't have to be exactly on there, but they do have to be close. So what we're looking at is a positive correlation. It looks like the taller you are, the more you weigh. All right, so let's look at these questions. What is the correlation of height and weight? Positive, negative, or none? We have a positive correlation between height and weight. Wow, it's almost filling in the answer for me. All right, how many people were taller than 64 inches and weighed more than 140 pounds? So we're gonna have to go back to the data for this one. And you can use the table or you can use the graph. So how many people were taller than 64 inches and weighed more than 140 pounds? So let's go to the graph. Taller than 64 inches. This is 64. So all these people are taller than 64 inches. 1, 2, 3, 4 people are taller than 64 inches. All right. There's 1, 2, 3, 4, 5 people that are 64 inches or smaller. All right. And since they said taller than 64 inches, that does not include 64 inches. So the question said, how many people were taller than 64 inches and weighed more than 140 pounds? So let's go to 64. And above 64, we have all of these. And here's the 140-pound mark. So nobody that weighed, nobody that was more than 64 inches, nobody that was more than 64 inches weighed less than 140 pounds. So all four people that were 60 or like taller than 64 inches, all four people that were taller than 64 inches weighed more than 140 pounds. So how many people are taller than 60 inches or 64 inches and weighed more than 140 pounds? There were four people that were taller than 64 inches and weighed more than 140 pounds. I really appreciate it if you use complete sentences because why not practice? What fraction of people were under 64 inches and weighed over 140 pounds? Okay, so we're going to look at this graph carefully because it's under 64 and weighing over 145. So under 64 would be these 1, 2, 3, 4 people. 1, 2, 3, 4 people weigh under 64. Once again, this person, I mean, not weigh under, are measure it under 64 inches. All of these people are less than 64 inches tall. All right. And so they want to know out of the people that are under 64 inches, like what fraction weighed over 140 pounds. So there are four that are under 64 inches, and there is one that weighs over 140 pounds. So one out of four. One out of the four people that are less than 64 inches tall weighed over 145 pounds. So 1 out of 4 is 1/4. So 1/4 of the people were under 64 inches and weighed over 140 pounds. That also means that 3/4 of the people were under 64 inches and weighed less than 140 pounds. All right. So we've done a lot with this scatter plot. We're finding positive correlations between height and how much people weigh, and then we're breaking down that data All right. And so this stuff will be helpful on your quiz. So please make sure, I mean, hopefully you did this before you did the quiz. Remember, you can take the quiz multiple times. So if you took the quiz and you didn't do as well as you thought you would, and then you did this assignment and it makes more sense, go back and take the quiz and you can improve your grade. So I hope that you're having success with this. Please reach out to your teachers if you have any questions. We're there for you. And yeah, like and subscribe if you feel like it. I hope you have a wonderful day, and I'll see you later. Bye.